Hello everyone, welcome to DCC NIT-A. Myself Tejas, and today I'll be discussing the problem B, comparison string from Codeforces round 149 or educational round 149. So we are given a string S of length n consisting of only less than or greater than characters. An array A consisting of n plus 1 elements is compatible with the string S if for every I from 1 to n the ith character of this string represents the result of the comparison between the ith character of A and the I plus 1th character of A. Okay. Now the cost of an array is the number of different elements in it. For example, for this array 1, 2, 5, 4, 2, there are 3 different characters, 4 different characters, 1, 2, 4 and 5. So the cost is 4. So suppose, we'll have a string S of length n, and we need to create an array of n plus 1. So we don't need to create the array, we just need to tell the the minimum number of elements that can make the array compatible. Now let's see, suppose our S is something like this. So I can place a 3 here, 2 here, 1 here, and again 2 here. So in this case we have 3 different characters, so the answer would be 3. From the example test cases. Okay, so if we consider the first and last test case. Okay, in the first test case we have this. Okay, so we have this. We can place a 1 here, 2, 3, 2 and 1. So in this case we'll have 3 different characters, so our answer is 3. In the last case we have something like this. So I can place a 1 here, 2 here, 1, once again a 2, 1, and 2, 1 and 2. So here the answer is 2 because we have only 1 and 2. So the first thing that may come into your mind is that we can form an array. For example, suppose I have this string. So since we have a greater than sign here, so I'll take a 2 here and a 1 here. Or suppose if I had something like this, then I would have taken a 1 here, I would have taken a 1 here and a 2 here. Now in this case, in the upper one, now I have a 1 here and I need an element that is smaller than 1. So I can just subtract 1 from this, so I'll have a 0. Now I need an element that is smaller than 0, so I'll put a -1. And then I need an element which is bigger than -1, so I'll increment by 1 and I'll put a 0. And similarly in this case I need an element that is smaller than 2, so I'll have a 1. Then I need something which is smaller than 1 itself, so 0, and then I can have a 1. Okay, so for these cases this logic might work. But if we have something like this, suppose if we have something like this. So if we go by the previous logic, we'll put a 2 here, then 1, then 0, then 1, then 0, then a -1, then a 0. In this case we are getting 1, 2, 3 and 4 elements. Okay, but we need to minimize, and Suppose if I had put a 2 here, so what would happen that if I had a 2 here, then I could have put a 1 here, a 0 here, and once again a 1 here, and in this case I would have 2, this 2, 1, 0. So our answer will be 3. Hence our previous logic fails. Okay, this would give you a wrong answer. Now what would be the approach to this problem? I'll discuss the approach now. The correct approach is that, okay, so the previous case was this. Okay, so suppose what I did previously was I put a 0 here, then 2, 1, 0, and then 1 again. So if I see here, I'll count the maximum number of consecutive similar elements from the string S. In this case our S was this. So what are the maximum number of consecutive elements? Here I have 2 consecutive greater than signs, then I'll again have 2 consecutive greater than signs, so our max is equals to 2. Why I'm counting this 2 is because I can place a 2 here, a 1 here, and 0 here. So our maximum consecutive, as soon as our maximum consecutive elements are satisfied, then what I can do is that I can repeat these values at any place. So this will be our maximum. I can repeat this value at any place. So suppose I had something like this, 4 and something like this. So our max is 4. So I can put anything, not necessarily 4, but we'll have to satisfy the condition. Then I can put a 2 here, a 0 here, then a 1, 2, and 3 here. So basically this is our maximum range, the maximum number of consecutive similar elements. Now for satisfying this one, we just took this part, reversed it and placed it here. So the right approach is to calculate the maximum consecutive elements. So suppose our maximum consecutive in this case was 1, 2, 3 and 4. So the number of elements that we will require to satisfy this maximum consecutive elements will be the count of this max plus 1, and this will be our answer. If you look at the code, I've initialized our max with 1 and our current with 1. Then I'll check if the ith character is equal to its previous character, then I'm incrementing the current value, and if this condition is false, then I'll be updating our max and I'll assign our current a value of 1, and then I'll take max once again, because for the last subsequence I'm taking this max once again, and our answer will be max plus 1, and this works.